We'll just get started. Extra 1 minute for me. So, hi, my name is Alexander Chatzizacharias. It's a little bit of a tricky last name. Any Greeks here? Well, not for the Greeks, but for the other people, a little bit tricky. I like bouldering. I have a way too expensive Magic the Gathering card collection, unfortunately, and I'm a really vivid gamer. I play a lot of games. I really enjoy playing games. And you'll see that probably a little bit back in the presentation. Any other gamers sitting here? Good, good. So at least you are at the right talk for sure. The rest, I'll try to prove myself. All right, I work at a small company in the Netherlands called J-Driven. We're like with 35 Java engineers. And at the moment, I'm consulting at routscanner.com for the Port of Rotterdam. And that is me, in short. So roughly 1.5 years ago, it was like the AI D-Day, right? So ChatGPT was released to the world. Everybody started playing with it, and everybody was like, oh, this is so cool. So I was one of those people. I thought, OK, this is amazing. How do I build this myself? Then I found out it would cost me a couple million, maybe billions. I don't have that kind of money. So then I started snooping around. How can I make something closely, resembling ChatGPT? And then there was something that I continuously kept reading about, and that was the term vector databases. And that is something that all those applications, all those chatbots, all those RAG systems, retrieval augmented generation that you hear about nowadays use underwater is a vector database. So I went on an explorative mission for myself to learn what that is, how it works, what can we do with it. And I just want to share with you what I did and how it looks like, and hopefully inspire you to try it out for yourself. All right, before we go into the database part, there's one really important keyword here, and that is vectors. Are there any mathematicians sitting here? OK, well, call me out on my bullshit if you hear it. But we have to start with explaining what a vector is, right? So mathematically speaking, if you look up vectors, this is the notation you'll often see. It's a letter with an arrow on top. And vectors are a mathematical construct that are very good in encoding length and direction. But if you used to game development, you've used vectors before. They are used to represent a pointy space, a 3D space, 2D space, for example. But in this case, vectors we could use them a little bit differently. So vectors have a certain dimensionality. This is a vector with 2 dimensions. This is a vector with 3 dimensions, and this is a vector with 8 dimensions. Now, I'll just assume you're all programmers here. If you see this, there's something so you'll notice you can actually say this is just an array of numbers, right? And the length of the array is the dimensionality. So if you have a length of an array of 8 numbers, you have a vector with 8 dimensions. It's pretty much the same. Not mathematically speaking, but let's say software engineering speaking. So what do we do with vectors, or what are the big tech companies doing with vectors? So roughly 10, 11 years ago, the first so-called vector embedding models came out, and what they did is they grabbed a piece of text and translated it into its vector representation. So they changed text into a certain vector with a certain dimensionality, for example, this. And then that went further, so we started with text, and then we went to images. So grabbing images and translating that to the vector representation of said image. And now we are in a state where we're trying to vectorize everything: audio, 3D models, point clouds. We're trying to see, OK, how far can we get with this vectorization of our data? And we do that, or the big companies do that, but you can do it yourself through the use of machine learning models. So they have models that are taught themselves, given this input, this is the vectorized output. And they have been trained on huge data sets over multiple weeks, a lot of GPU, a lot of money. And that is what we call a so-called embedding model. So maybe you've heard of it, the word embedding. If you, there's also, maybe you've heard of OpenAI having embedding endpoints. Those are endpoints you can call for OpenAI with your data, and it will return the vectorized version of that data. So when it comes to vectorization techniques, the first one was Word2Vec, released in 2013 by Google, and a couple of years later, Glove. And those had a really big issue. They didn't understand context of a certain word they were in. So the same word, a word with different meanings in different contexts had the same vector representation, which made it kind of unusable for semantic search, right? So it's always the same. And then the transformer models came out a couple of years ago, and those actually understood context of words. So the same word in different contexts with different meanings would have a different vector representation. And that is really what unlocked the whole LLM GPT revolution, so to say. And right now we have models like OpenAI Clip that is really cool, that can get different sorts of inputs or images and text and put them in the same vectorization space. So you can search images with text or text with images and stuff like that. So that's really cool. All right. So those are vectors in short. Then we have vector databases. Everybody knows what a database is, right? Great. But what is a vector database? It is a really purpose-built database. It has one purpose, and that purpose is to store and index high-dimensional vectors. And with high-dimensional, you can think maybe 524 dimensions or 1024, sorry. But there are some databases that will go up to a million dimensions, for example. And the more dimensions a vector has, the more accurate the representation is, of course, right? And then they all do the indexing and the retrieval using so-called nearest neighbor search algorithms. Really, if you're into algorithms and how they work, if you read up on the crazy stuff they did to make this work on scale, it's really interesting. And of course, you can store all kinds of metadata associated with your vector objects. So then you can retrieve your object using the vector embedding, and then you can grab the metadata to actually build your applications. All right. Let's say there's like this tech illiterate project manager coming to you and is like, hey, I have this, keep hearing about vector databases. Everybody's talking about vector databases. What is the answer I would give? And that is this, that it's a database that facilitates effortless and swift semantic searching of data. And then semantic here being the keyword, of course, because if you want effortless and swift search on your data, you probably would use Elastic or maybe your own implementation or just a relational database. But if you really need semantic search, then you can think about using vector databases. Right now, they're mostly used for AI applications, vector databases, but they're not inherently AI. What I'm trying to say with that is there is no trained models within a vector database, nothing like that. A vector database is actually a really specialized application with highly scalable retrieval and indexing algorithms to put your data in and get your data out as fast as possible. And themselves don't really have any AI built into them. So yeah, that means that you can use them for anything you want to store any kind of numbers. I, for example, played around with trying to store a Minecraft world in a vector database. I don't know if anybody's played Minecraft. It's a pretty good game, right? So it didn't work that well, but it was still fun to try out. OK, so when it comes to indexing vector databases, we have all kinds of algorithms, linear search, of course. You put something in, and it linearly searches through all other entries in the database to index it. As you can imagine, it doesn't scale very well. K nearest neighbors is quite popular algorithm, of course. Shout out to Spotify for approximate nearest neighbors. Oh yeah, love the naming. And its follow-up called Voyager. And then my favorite is hierarchical navigable small worlds. I would never have imagined I would have a favorite algorithm, but here we are. And that indexing happens through the use of so-called distance metrics. So when you put a vector in a database, it's going to calculate the distance to the 0 point, for example, of the database or to other objects in the database. And that can be done through Euclidean distance, that is just meters, like we know it. cosine distance having Manhattan distance dot product. The mathematicians here would see this and are like, oh yeah, I know all this. Other people would see this and maybe, I'm not sure what this is. It doesn't really matter unless you're really fine-tuning the search on your database. Do you know what the difference is between distance and similarity? So when you're asking for a distance, you're asking how far are these objects apart from each other. And when you're asking for similarity, you're asking how close are these objects to each other. Now you might think, okay, this is exactly the same. What are you talking about? But basically, the smaller the distance is, the closer objects are to each other. The bigger the similarity is, the closer the objects are to each other. What's really important to understand is that distance calculation and indexing always happen within the same so-called vector space. So once you create your database and start inserting objects in there, you have to define the vector space you're going to be putting objects in. So, for example, by schema, or you can by table, or by object, by JSON. Every database has some way for you to define the vector space it will operate in. And that is really important because of the dimensionality of the vectors. So if a vector with 512 dimensions is checked against a vector with 384 dimensions, then mathematically it is possible, but you won't get very good results. It's going to be a little bit iffy. So like this, they ensure that the dimensionality within a vector space is always the same. Now, when I hear something as vector space, and being a gamer, I figured, okay, I can probably do this. So I try to represent the data in one of my vector spaces as, well, space. So this is one vector point in the data point. It is, well, Longbow, and it's a planet. And if you fly around, you'll see more and more data points in this, well, vector space. Now, I will be the first to say this is not necessarily the most user-friendly way to look at your data, but it's the most fun way to look at your data. But what's really important, so these are all the data points in this vector space, and what's really important is that you see these clusters that are being formed. And that is exactly what you're searching for. So once you start vectorizing objects, objects that are similar to each other end up being closer to each other in the database. So when you do a search, for example, a little bit spoiler for what's to come, for a nunchaku, it will, the object or the vectorization that you're searching for will end up here closely, find the object you're searching for, and turn that to here. And if you look at the objects close to here, we have a mace, we have a boomerang, we have a scimitar. So there's things that are similar to the nunchaku. And that is really what vector databases are really good in, this similarity. All right. If we look at the vector database ecosystem, there are quite a lot of them out there. No problem. These are, I think, after a couple of years, these have cemented themselves as being the biggest vendors that only have like a vector database. What's maybe interesting for you is everything on your right side is open source, and on the left side is closed source. Redis is open source, but the Redis stack things are closed source, and it's part of the Redis stack, so that's why it's closed source. And Elasticsearch, I don't know, I know they have a booth. Anybody from Elastic here? Hi. Is it open source or closed sourced? Do you know? So that is exactly the issue I had. Right, because I was reading through the documentation and it was like, yeah, we're really open, we love being open, but in this case, so I'm not sure. Some databases offer built-in embeddings, which is really cool. That means that once you don't have to do a call to OpenAI or a Hugging Face first to get your vectorized data. You can just insert in the database or call the insert for the database, and the database will embed it for you. And often they do that through a separate Dockerized model that they have running next to the database. And then, of course, they all want to earn money somehow, so they all offer managed services. Postgres has an add-on called PG Vector. You can get it managed through Supabase, for example. So yeah, if you want a managed vector database, one of these. I did it. They're quite pricey right now because of the hype. So try it locally first, I would say. Of course, you want to call or insert or take things out of the database. A lot of them have REST APIs. By the way, all of them have a Python client because Python is king in AI, right? So all of them have Python clients. Some of them have REST APIs you can call. Some of them have JavaScript clients or CLIs. Some of them you can call through SQL. And Vespa you can call through YQL. I think it stands for Yahoo Querying Language, but I'm not 100% sure, which I've never used. It's an interesting choice. All right, so that's a little bit of the landscape. Of course, the MongoDBs nowadays, MongoDB and Neo4j, the big database vendors also have like a vectorization module that you can use, but I didn't really experiment with those because I like small, specialized companies more, I think. All right, so let's start implementing our own search, see what we can do with vector databases. For our stack, this is what we'll be using. I chose VV8 for persistence layer. Our backend will be a Kotlin Spring Boot application. Kotlin, why Kotlin? Well, Kotlin is the best language on the GVM, changed my mind. And we'll be using a Unity frontend. Who here has no idea what Unity is? Everybody knows Unity? Nice. It's a little bit of a bad boy right now, right? With what they did last year. Try to commit corporate suicide. And they're still trying as far as I think. But yeah, I'm quite proficient in Unity, so I just stuck to them. All right. So I chose VV8 because it's open source with some paid cloud services, so it's really nice. It's completely modular, so all the models to embed your data can be run separately next to the Docker of the database itself. So that really allowed me to pick and choose which model did what and how they worked. Their documentation is actually pretty decent. The amount of what the fucks per minute when implementing it was quite low. And their Java client is also pretty decent. And of course, I can run, with this setup, I can run everything offline. And seeing how the Wi-Fi was here at the conference is a good decision. So good job past me. All right, so the architecture. It's pretty simple, I think. So through a REST client, we'll be talking through Unity to our backend. There we have the Java client library for VV8, which is doing GraphQL or REST calls to the Docker container where VV8 resides in. Any architects here? And then people are saying, is architecture a dying profession? Well, so I had some people ask me, why don't you just call directly through Unity to the Docker container? Because, I mean, in the end, it's just REST calls, right? And to that, I say, I'm a backend developer, and if I see a chance to add an abstraction layer, I'm going to take it, god dang it. So that is exactly what I did. So a beautiful abstraction layer there. OK, so today we'll be using coasting distance as our distance metric, hierarchical navigable small worlds as our indexing algorithm, and some BERT, ResNet 50, and clip models for stuff. These three are not super interesting, but I added them for completeness. Coasting distance is basically 1 minus the coasting similarity, which is this formula. But what's really interesting for you, I think, if it comes out 0, that means two vectors are identical. And if it comes out 2.0, that means that the vectors are opposite. And for today, we're going to cap it at 0.9. So we'll only return objects that are within 0.9 distance of each other. So yeah, if you get like a Java class and a C# class and put them in the database, then the distance would be close to 0, right? Because they're practically the same. Or at least that's what I've been told. And if you grab a JavaScript script and a Java class, they should be quite opposite, unless you're doing some really funky things with Java. And then hierarchical navigable small worlds are a bit trickier to, well, first pronounce, secondly explain. So I tried to do it like this. So let's say we have, these are all the data points we want to be putting in a database. So what happens every single time you're inserting something in the database, the algorithm or the indexing algorithm is going to do a proximity search around the new object that just entered the database. And then it's going to create a so-called adjacency graph or neighbor graph or friendship graph. It has 1,000 different names because we're really good at naming things in our industry. But yeah, basically you're creating a graph of X connected nodes, right? And in our case, X is 3. So we're searching for 3 closest neighbors. And it does that for every single object that enters the database. Now, at some point, there's a random chance that one point is going to be duplicated into a higher layer, a second layer. So we're going to have a layer 2 on top of layer 1. And then it's going to do exactly the same. So for every object that gets duplicated into the higher layer, it's going to make a second proximity adjacency neighbor graph. And then there's again a smaller random chance that it's going to go to a third layer, a smaller layer. So what you see here is actually you have like a multi-graph structure where the topmost graph is not very dense and the bottom graph is extremely dense, right? So let's say this is where our search is coming in. So this is basically the vector position. And then what the algorithm does is from the same entry point on the topmost layer graph, it goes to the closest node to where you're searching for. And then it's going to use that node as an entry point in the lower tier graph. And then again, it's going to go to the closest node. And again, use that as an entry point in the lowest tier graph. And like that traverses from the least to the most dense by skipping a lot of steps, as you can see. So if we had to go through there, we will have to do many more steps than what we did right now. So if we add everything, clean it up a bit, and then do a search that would end up here somewhere. Again, we'll go to the nearest node, find the nearest node, use that as an entry point, go to the lower tier, and then find that as an entry point, and again, go to the lower tier. If you're very good at algorithms, you might have noticed that this is an evolution of an evolution of an evolution of evolution of skip lists. I don't know if you have ever used skip lists in the past, but skip lists allow you to basically skip objects in your list. So this is basically what we're doing here. Check. I'll take that as a yes. Okay. Does anybody get this reference? Yes, it is? The Matrix, yeah, thank you very much. So there is this scene in the Matrix, right? Who has not seen the Matrix, the original Matrix? One person. Well, a pretty good score. So there is a scene in the Matrix where Neo is asking for a lot of guns, right? And they give them a lot of guns. But there's a huge plot hole here. How is he going to find the gun he's searching for? So we're going to help him. So we have a little CSV with 3 properties, the weapon name, the weapon type, the weapon range. So example, Excalibur, sword, and the range is short. And when we vectorize that, what's going to happen is we're going to lowercase everything, concat it together, so we'll get weapon, Excalibur, short, sword. If you want, you can choose to also vectorize the property names. So then we would get weapon, name, Excalibur, range, short, type, sword. But in this case, we don't do that. We only vectorize the actual data. And then through a BERT model, this is a little bit of, we have a 384 dimension vector, and this is a little bit what it looks like. All right. Spoiler alert. So let's go and try this out. So it is like you're watching the movie, I know. So Trinity is saying there's no way this is going to work. Neo's like, I'm pretty sure I'm badass enough to make it work. And I'm glad he tried to make it work because it gave us that elevator scene in the Matrix. This is just amazing. Now, question, maybe a little bit of a weird question. Anybody has a favorite weapon? Sorry, a baseball bat. A bazooka. I guess you could, right? Anything else? A what? Sky? Oh, scythe. This is how you write it, I'm pretty sure. We could do, I need a scythe. A scimitar. Oh, pretty close, right? If we look at the distances, so the scimitar was 0.55 from what we actually searched, which was I need a scythe. And of course, if you add more words like I need a, or it does remove the adjectives, that's what they called the and stuff, the and a and things like that. But need is going to be vectorized, so that could add some noise in your searches. So, but it's really because it understands context. I can say something like a Japanese weapon, and then we get an odachi, which is a Japanese weapon. Trust me. And if you look at the data, we didn't do any. So this is basically the CSV we are loading in, and we didn't do anything categorization or whatever. For the odachi, I never said that this is from Japan. When this was vectorized, when the embedding was created for this, the context was created around it that it's indeed a weapon that is coming from Japan, which is pretty cool, right? Okay, so last one for the Call of Duty players. How about something explosive, which is indeed an RPG? Which is indeed the same model as a bazooka. I don't have infinite time. All right. So, I play a lot of Dungeons and Dragons. Any other people that play Dungeons and Dragons here? Great. If you do not resonate with Dungeons and Dragons, just everything I refer to as wizard in Dungeons and Dragons, just think of Harry Potter with Dumbledore. Which everybody should know, at least here in the UK, I think, right? So we have a forgetful wizard, or Dumbledore, that was walking through the woods, and at some point he's ambushed, and he doesn't remember any spells anymore, so we're going to help him search for spells he can cast to defeat the evil thug. And again, that is done through a BERT model. So if you look at the data set we're using here, so I loaded all the Dungeons & Dragons spells in the player's handbook, and as you can see, this is a lot of text. By the way, all my data is taken from kaggle.com, which has a lot of open source data sets. It's amazing. So this is a little bit more than the 3-word CSV we just used. But to make this work, you really need, because it was a lot of machine-readable data, right? A CSV is typically something you want a machine to read in. So what we did to make this really searchable is we created a description that is very semantic. So the spell can be casted by these classes. This is the level of the spell. The magic school is this, blah, blah, blah. So a semantic way of describing everything in the data that we have. And then we basically say, hey, all these properties that I have in my CSV, I don't want you to vectorize them. I want you only to vectorize the name and the description. And that is what we do here. And like that, we can make searchable data. So what I'm trying to say here is, if you're thinking, I'm just going to grab my machine-readable data, throw it in a vector database, and amazing, I don't think that's really going to work. It could. I think you do need to create like a semantic description of what your data means, which you could use ChatGPT for. All right. So this is our wizard / Dumbledore, ambushed by the thug. Anybody played the new Baldur's Gate game? Baldur's Gate 3? Yeah, it's almost the same, isn't it? They worked for 7 years on that game. I don't get it. I'm joking, of course. Amazing game. All right, so the D&D players, do they have a favorite spell they use? You do go with the heavy stuff immediately, huh? All right, so we're doing search, and indeed, you can see power word kill is, and then power word stun, and then symbol. I don't know why symbol got there, but so, and then, of course, we can cast it, and then death. Let's bring it back. For endless torment. Anything else? The traditional. I want a fireball. And then again, you can see fireball. So it was not our biggest hit, which was pyrotechnics, which also has a lot of fireworks and smoke and stuff like that in its description. But we got fireball, so that's pretty good. Or firebolt. And then we can do indeed, again, death. And then you can do something explosive, for example. And then again, delayed blast, fireball, pyrotechnics, because the context of a fireball is most of the times that it is indeed explosive, right? So like that, you can find it in your similarity search. And again, perfect. Endless torment for the poor thug. Okay. So that is text. So that is all nice and all, but we can also do images, right? And that is also quite interesting for a lot of use cases. Has anybody played this game, Pokemon Snap? I don't get it. I really don't get it. That game is so weird. You're just on rails and you're throwing apples at Pokemon and taking pictures of them. And but it was really popular. A lot of people playing it. Even on the Switch, the new Switch release, a lot of people play it. So obviously we're going to recreate it with fear of being sued by Nintendo. So we have Ash that is walking around. And he flips his hat because that is what he does. And then we're going to take a picture of a Pokemon that we see and hopefully find the Pokemon in our database. So if you look at our datasets, I have a CSV with all the Pokemon, or I don't know how many there are right now, but a lot of Pokemon. But mostly for the number, because I was interested in the number of the Pokemon. And then I have these icons for each Pokemon. So this is, for example, Valor, thank you. And then we have, you guys are good. And what is number 9? Blastoise? Very good. No, 9 Blastoise is correct. What is number 25? Sorry? No, you have to guess. But it's Pikachu. Everybody should know Pikachu, right? It was crazy. I did this at another conference. There was a guy. He could go all the way down to 200 something. I was like, okay, what is number 285? I was like, whatever this is. Does anybody know what this is? Sorry? I mean, I'll believe you. Okay, wait. We are living in an age of fake news and AI-generated things. So 285. Paras. I'm sorry. Oh my God. You were right. I tried to sell you. Well done. I tried to sell you fake news. Well done. All right. So we are. This is Ash, as you've seen him from the anime. We were walking around, and we see this is 25. Yes, that is correct. All right. So if I take a picture, it is indeed Pikachu. So what happens is we're taking a snapshot of the camera frustum, and we send that to the database. And the database is trying to match that with the icon in the database, which is, well, exactly what you see there, which is Pikachu. So yeah, that's pretty nice, right? If we walk around, there are more. And this is it's an easy one. Beedrill. It's perfect, right? So what if I tried from a different angle? No, it's Prinplup. Or if I try this angle, no, it's skarmory. I know that one. So as you can see, it's not perfect, right? You're not always finding what you're searching for. There is another one here somewhere. Oh, stuck in the trees. Always happens. All right. And this is? No, it's Joltik. The vector database doesn't lie, I'm afraid. Okay, so what's happening here? It's so a little bit. So what you see here, this is what the camera frustum is seeing right now. So all the noise in the world, like the grass, and et cetera, the camera doesn't really see. That sends the image to the database. It just sees yellow with a Pokemon in it. Has anybody noticed what kind of yellow this is? This is Pikachu yellow, yes. So why did I make it Pikachu yellow? Well, to find Pikachu. So what's happening is, if you look at the icons, oh, that's wrong icons. Spoiler alert. Here we are. All right. So if you look at the icons, they're all the same type of icon. So white background with a cartoony Pokemon in front, and they're from one side, one perspective of the Pokemon. And the image I take is a 3D image of the Pokemon, right? From different size, different perspectives. And the vectorization model you use doesn't necessarily understand Pokemon. It doesn't understand the context that this image is, okay, this is PG of PG, right? Yeah, PG of Pokemon, of Pidgeot, one of the two. To solve that, you could train your own vectorization model to understand Pokemon with fear of Nintendo coming after you. Or what you could also do, for example, is grab multiple data sets of Pokemon images from different styles, different perspectives, things like that. So have more reference material to find the image that you're searching for. Because you don't know what your user is going to input, right? If you make something like this. So the more, well, ammunition you give to your vector database to find what you're searching for, the better. All right. So our wizard / Dumbledore is really, really forgetful. So he walked a circle and he's back where he was, but we're going to make things a little bit more fun. So yeah, this time what we're going to do is using the same input as we did before. We're going to grab the name of the spell we found and put it back in the database to do a search for an icon that matches that spell. So we want to find an icon that looks like the spell that we want to cast. If you look, well, at the icons I just spoiled over here. So these are the icons. So I have a database. So I loaded in the database 213 icons. I bought them like 10 years ago from a Humble bundle. I don't know if people use the Humble bundle here. So it's amazing. You can buy things for cheap, and they donate 70%, I think, to charities. So about it, I like to make games sometimes in my free time, as you might have noticed. And I bought them like 10 years ago, and my mother was like, "You're wasting your money. Why would you buy this?" Well, here we are. 10 years later, finally. And as you can see, they're pretty good. They're pretty high res. They have no white pixels. I forgot to mention that on the Pokemon example. So white pixels or transparent pixels are defaulted to white or black. That is why all the backgrounds were white. And then the more white you have in your image, the easier it's going to match white things. For example, that is why you saw Scarecrow in Pokemon, because it had a very metallic color, very white. That's why it favors things like that. But this is not the case here. These are pretty good. And they're all 256 by 256. All right. Over here. So whenever I give a presentation, I have like this personal goal that I need to show an explosion to people. So I'm going to start with that. a fireball. And as you can see, I can argue that this is indeed a fireball, right? Nobody disagrees, I assume. Good. So what happened? So the icons were not labeled in any way. So the name that you saw of the icon in the IDE, that was really the name that I just grabbed it and put it in the database. So just icon and a number. So no labeling, no whatsoever. And I used the OpenAI clip embedding model that can embed images and text in the same vector space. So you can cross-search images with text. So what happened is I searched for fireball. I found a spell called fireball in the database. I grabbed the name and then searched the icons vector space for anything that looks remotely as a fireball, which, you know, pretty cool, pretty good. And then, of course, we can cast it, and then, bam. And that was my explosion quota reached. All right. Anything else you're interested in? Laser dust? Oh, glitter dust. Dust Devil, Programmed Illusion, and Shadow of Moil. I don't even know the Shadow of Moil spell. But if we cast this, let's see what we get. Oh, fireworks. Death. All right. Bringing back. Glitter dust? So this is really an interesting point you're making. So in a vector database, given the same input, you'll always get the same output. But what's really beautiful to me is you never know what that output is going to be. So there's a little bit of gambling going on here. So you are never really sure what you're going to get out of your vector database, giving a certain input. But you can be sure that you'll always get the same thing out of it. The glitter dust, yes. I don't know. It is indeed a different vector. So then we can, for example, cast Magic Stone. Again, fireworks. So he flew really high this time. Then we can do, for example, something icy. And we get investiture or ice knife. It is a knife, not ice, unfortunate. Or so if we cast this, we'll see it's electric, it's blue. So what I did here is all the icons I extract the average color out of an icon and then match a particle effect to the big colors, like to blue, green, yellow, red, etc., etc., etc. So if I do something, for example, like poison cloud, stinking cloud. Oh, it's again blue. We just had blue, right? Good memory. So if I just do poison and protection of poison, you'll see it's going to be a green puddle. So yeah, that's really cool to me that, you know, just by adding icons in a database, suddenly I can do much more just by extracting colors, playing with colors. You know, they can match particle effects left and right. And that is something that really would take really long time to do before I could put these things in a vector database, because I would have to classify all the icons myself, tell, okay, this is a fireball and this is a knife and things like that. So last chance, anybody that wants to see something, maybe try to break my demo. You took that one very literally. Try, break my demo. Let's see what we get. Command, reality, a shield. so that we can cast, for example, reality break, and then we'll again see. So when I can't extract an average color, which is one of the big colors, then I just do all colors. So yeah, so again, and what the vector database is going to do, it's always going to try and match something for you, right? So if we look at the last one, try write my demo. Maybe I shouldn't have logged the whole image as base64. Big image. Here we are. So it's going to be, yeah, on 0.69. So it's still pretty far away from actually being considered close, but we at least find something, for better or for worse. All right, so I'm a big metalhead. Any other metalheads here? Any people that really hate metal music? Okay, good. So I'll assume non-metalheads don't know what this is. This is a band called Death Clock, and they have this coffee jingle, which is like the best thing ever. It should be the international anthem for coffee, in my opinion. But and what we're gonna try to do is gonna try to make Shazam, but then for metal lyrics. So as you might have heard, sometimes metal can be a little bit grunty, a little bit difficult to understand. And then you want to get the lyrics, and you have no idea what they're saying, and Shazam is not really working. So what I did is I put all kinds of songs, song lyrics in the database. So I have songs from Beyonce with all the lyrics, Coldplay, Ed Sheeran, and then I put 3 metal songs in there: Metallica, Enter Sandman. That one should be known by a lot of people, right? And then Dragon Force, Through the Fire and the Flames. I don't know if somebody knows that one. Also, Guitar Hero. Good. And then we have Death Clock with a Duncan Hill's coffee jingle. And that is the one that we'll be searching for. So I embedded the OpenAI Whisper model, that is a lyric transcriber, music transcriber, into Unity. It's going to listen to the song, which is the Duncan Hill's coffee jingle. On your left side, you'll see the transcribed lyrics. So what does the model think it's hearing? On the right side, you'll see the actual lyrics. That is what they're actually singing. And every half a second, we'll be querying the database to see if we can find a match between the lyrics and the Duncan Hill's coffee jingle. Anybody want to place bets? Who thinks that we will find the song we're searching for? Okay, a couple people. Who thinks, no way, Jose? Who thinks it depends? Oh, it depends on what? That is the question we really fear, doesn't it? Isn't it? Okay, so it's transcribing the lyrics right now. It takes a couple seconds. And then it's going to start playing. Hopefully not too loud. Oh, this is fine.
Folks like coffee.
So we have Beyonce, Post Malone. Then we have it for a bit. Lady Gaga. Can be metal, I guess. Ed Sheeran. Dragon Force. Back to Coldplay. Selena Gomez. It really likes Beyonce for some reason. Post Malone. A lot of Post Malone. And what's really funny to me, and I really don't know why, the guitar solo is just all Ed Sheeran. I don't know exactly how high-pitched his voice is, but but yeah, Beautiful People by Ed Sheeran, people. So as you can see, we had a very brief moment where we actually found what we were searching for. So to that, all I have to say is, when the inevitable revolution of AI comes and they start taking over, if we just start grunting to each other, then we'll have no idea what we're saying, and it's going to be an easy one war. So that was all I had to say for today. Thank you a lot for watching. Thank you for being here. Thank you. If you have any questions, I think we have time for one or two, and feel free to rate the session on the app if you liked it or not. I mean, any questions? All right, now I'm here. If you that's good. I'm here if you still have any questions. So enjoy the rest of the conference.